Okay, the first thing is try to visualize what they're giving you over here. And again, it doesn't be very accurate, but enough to understand what the integration looks like. And at 0, this function here would look like, let's see, 1 over 1, so just 1. So that's the point, 0, comma 1. And at 2, what's it going to look like? Let's see, that would be 1 over root 5. So it's over here. So at 2, it's this point over here, which is 2, 1 over the square root of 5. And this thing sort of looks like this over here, all right? So the other thing I want to point out there is there's a line x equals 0. And x equals 0 looks like this over here. So use the shell method to get the volume obtained by rotating the solid region underneath the graph. Well, this is the graph we're talking about over here. About the line x equals 0. Yeah, we're going to rotate it about this, x equals 0. And we're going to rotate it about this. All right? Let's take a look at that. And a representative rectangle again. Looks sort of like this over here. I'll put that down. Differentials dx. The height of this thing is going to be, let's see, that's pretty simple. It's just simply going to be 1 over the root of x squared plus 1. I'm going to extend this, or rotating it, and that's going to be, the r now is 2 pi, and again, this is the radius. The radius corresponds to the x-coordinate. And I can write my integral down now. What's it going to be? Let's write this down. Whoops, go back to black ink. We're going to go from 0 to 2. Yep. 2 pi x. I'm just doing the box now. The height of it, let me write this now as root x squared plus 1 in the bottom, and dx. All right, so the problem now is doing the integration. We got the integration down. I want to point out this is an important milestone to reach. And this is written right over here. And just make sure they're the same, all right? What do we have to do now? We have to do the integration. Let me erase this business over here. And I want to talk through the integration. In Math 121, Calc 1, you learned about U substitution, and you should take advantage of that. What I would probably let U equal x squared plus 1, and du would be 2x dx. All right, so I'm going to go over here, and I'm going to start to copy things down now. So I'm going to go to the land of u's, and if I'm in the land of x's and x is 0, looking at the lower limit, well, if x is 0, u would be 1. All right? Now, if x is 2, the limit for u would be 4 plus 1, which is 5. All right? Now I'm going to start to look at the problem, and I definitely see some things. I see this. And what's that going to be? Well, that's going to be the root of u now. All right? Now I want to point out, I see 2, I see x, and I see dx, and that equals du. And I get a pi there. All right? So what I'm looking at now is an integration that's actually easier for me to do. And let's write this down now. And what are you going to get? Pi, 1 to 5. This is u to the minus 1/2 du pi. I'm going to increase that exponent by 1, so it'd be u to the 1/2. Divide by half like multiplying by 2, and evaluate that from 1 to 5. And what do you get? 2 pi root 5, that's the upper limit, minus the lower limit, root 1, which is 1. Put a box in that, commit to that answer, look at the key, make sure you're matching the key. And we are. We're getting exactly what we expected to get. Thank you.